IMAX3 begins. The third episode is What do you mean by calculation? Let's review the last video. Computers like data arranged with no gap and in order of use. Data should be aligned to the boundary for getting at once. Don't try to rearrange the data every time. This video is on what is calculation. Everyone has the impression that computers can do a lot of calculations. But what kind of calculations do computers do? The answer is simple. The only meaningful calculations are addition and multiplication. Some people may choose addition, subtraction, multiplication, and division. But subtraction is adding a negative number, and division is multiplying by a number less than 1. There are also shift and end, but they are additional functions because they only cut data. A computer is just a machine that can do addition and multiplication. Can optical computers and quantum computers properly add and multiply? You can do amazing things with multiplication and addition. The blue-colored 5x5 grid on the left is part of a photo with something in it. Multiply the 3x3 red squares by the green squares and add them together. The answer is 2, because there are 1 pair of 1 times 4 and 2 pairs of 1 times -1. Write 2 in the purple place. If you shift the red frame one by one and calculate the whole picture, you can calculate a lot of purple. 2 indicates that there is an edge. This calculation is called the Laplacian filter. Now let's find the shape of the edge. On the left is the edge we calculated earlier. Let's calculate if there is a diagonal line. The green 5x5 squares are the numbers used for multiplication. Line up ones in a 5x5 square diagonally, and line up negative ones elsewhere. Then, for purple, multiply by green and add it all up. In the case above, if you multiply the purple number by 1 and add it to the green number, you get 10. Other parts are 0. Now for the case below. Edges are horizontal lines. There are 4 pairs where purple is 2 and green is -1. If you add them all up, it's 2 minus 8, which is -6. As for what this is doing, it's just a calculation of plus when it hits the pattern you're looking for and minus when it's off. If you do this calculation for the whole photo and get 10, you know that there is an edge of the shape you are looking for. 6 or more is enough to find even the slightest difference. Search for various shapes, and in the next step, if you calculate whether there is a combination of shapes, you can calculate whether a face or a cat is in the image. AI's image recognition is like this. Computers find patterns by themselves, not by humans. That's amazing. Finding patterns and recognizing using patterns can be done with just multiplication and addition. By the way, I said that computers like data that is lined up without gaps in the order they are used. What is the order in which data is used in the previous calculation? If the size of the photo is 32 in width and 32 in height, 1024 boxes are lined up in a row with 8 boundaries in between. The data in the red frame are in discrete places, green is continuous, purple is one place. The red box crosses the boundary, so it requests the data a total of 6 times. Green twice. Purple is only used once, but since it is only used in one place, the remaining 7 boxes will be thrown away. The convolution method, which collects many inputs and adds them all, is a very time-consuming and unpleasant calculation to fetch data. I said that all you have to do is multiplication and addition, but the system to get the data is more troublesome. It means that you can't make a computer with less energy even if you make only multiplication and addition. In order to make the data arranged without gaps in the order of use, you can reshape the data like this. Put the data in the red frame into one column and arrange the next data in the orange. Copy the green data for orange and make it the same length. By doing this, the locations of the data in the red frame and the data in the green are aligned, and the continuous data can be lengthened, so the computer can move easily. The calculation result will be long, so you can reduce the number of boxes you throw away. But I told you not to think that you should reshape the data every time. In order to reshape the data, it is necessary to go once to retrieve the data in the original order. Even if it takes time to reshape the data, if the overall calculation time can be shortened, it's okay to do it. But both blue and green are increasing by copying data, so they need more space. It's no use trying to use only the good parts without sacrificing anything. Optical computers, quantum computers, even if their calculations are just amazing, they won't be able to surpass current computers. Rearrangement is not good. There is a smart way. First, place 9 memories vertically. Then, pour the photo data only once from the top. From top to bottom, the 3 memories pick up the first row of the photo, the next 3 memories pick up the second row, and the last 3 memories pick up the third row. Once the data is in, from each memory, take the red box, multiply it with one of the green boxes, and send the result down. In this way, each memory should be fetched from the left side and multiplied. If you add the results you get from above and send them down, the total will come out from the bottom. If you just write it in the purple box, the calculation is done. By the way, with this method, the purple boxes will fill up seamlessly. The irregular flow of data has become regular. Another nice thing about this method is that it simplifies the construction of the computer because you don't have to pull 8 boxes out of each memory at the same time. This method can be much faster. When the calculation starts using the red data, the red arrow that sends the photo data to the memory becomes idle. You can use this time to send the 4th row data further to the next memory like the orange arrow. After completing the calculations up to the right end of the photo, just shift the memory area down by 3 spaces, and you have the data necessary for the next calculation. That's amazing! You will be able to calculate seamlessly without having to rearrange. What kind of name is this? It's called 3rd generation CGRA. You can search for it. In conclusion, quick data access is more important than calculation. Reshaping for simultaneous calculation is really good. Simultaneous calculation with no reshaping exists. If you remember these basics, you pass this time. Well, that's all for today. If you want to study more, visit Amazing Data Flow Centric CGRA series.